Hello. Hello. Okay.
Yes.
Uh,
Hey, how are you?
I am fine. And you?
Doing good. Hey, man. Thanks for joining right away.
Okay. Thank
Pretty
you.
quick.
Okay. Okay. So basically, in this time, I also try to share my all of the project work which I already done. I also try to share with you, so then you can easily understand what I will do for you. Okay. So so I simply share my screen. Just a minute.
Yeah. Yeah. Before you do that,
Yeah.
so are you currently a student? Uh,
Yeah,
um,
yeah. So I am currently a student, but I have also my own institution. It's called the Study Hacks. This is the Institute of the GIS and Remote Sensing. I try to learn all of the people who want to learn the GIS and remote sensing, basically Google Earth Engine or remote sensing analysis. And
okay.
in the meantime, I also try to train the more than 3,000 people around the whole world within only for the 1 year, and a lot of people will be join and come with my institution for learning the remote sensing.
Yeah. And you go, well, I mean, I hope I say your name correctly. Can you pronounce your name?
My name is Mijan.
Nijano, is that?
Mijan, or short name Mijan. Mijan.
Nijan. Okay. Okay. Nijan. That's impressive, Nijan. That's awesome. My name is Ilango.
Yeah.
I'm in the United States. I run my own company in the water, wastewater, stormwater. I don't know if you looked into my company. My background is in civil engineering, and I have done a lot of GIS work in my life. So you piqued my interest. So that's what I just reached out
Yeah.
to you and see. Love to know. Yeah, you can share your screen now. And you are in Bangladesh, right? Are
Yeah.
you in
So
Bangladesh
now
now?
I am from Bangladesh. Yeah.
Okay. What place in Bangladesh are you?
So I am
Dhaka
from
or?
Dhaka. Yeah, yes, the capital of Dhaka. Yeah.
Okay. So I'm from India, but I'm actually in the United States for 20 years. I'm in Kansas City. So we do a lot of GIS work in the US. We're kind of branching out in the India recently. Yeah, that's kind of my background. Um, that's impressive. You're a student. You're training people all over the world. Kudos to you, man. Congratulations on all your
Yeah.
success so
Thank
far.
you.
So, okay. All right. Let's jump in. I love to see what you got. I mean, I looked at your YouTube videos and everything. It looks pretty good. So I love to see what other projects you have done so far.
Okay. Thanks. Okay. So now can you see my screen?
Yeah.
Okay. So I simply open my slide. Basically, in this time, I try to discuss about my all of the project work which I already done using the Google Earth Engine platform, as well as also some my research paper or research work. I also try to share with you. Okay, so let's go. So first of all, this is the one kind of web application. So mainly in this web application, we just use for the making the time series chart of the normalized difference vegetation index over a time period, such as 20 years time period. What is the condition for any specific location? So anyone can go to this web application and then click on the map. It automatically showing the result over a period of time of NDVI. What is the temporal changes of NDVI? We can easily find out. So basically, this web application I developed for the Bangladesh region. Basically, in this time here I use the MODIS satellite imagery and use the Google Earth Engine platform for developing this NDVI time series chart over a period of time in Bangladesh. Okay, so this is the another tracks also you can see. So basically this is the LAI or leaf area index. So basically we are using the leaf area index for monitoring the what is the condition of the leaf or what is the condition of the forest leaf in a specific region. So basically in this time anyone can go to this web application link and they can easily draw their region of interest. So simply draw the it automatically when draw this region of interest, it's automatically showing the region, what is the condition of the leaf area, as well as also it provide you the what is the leaf area index time series analysis, yearly time series chart we can also provide it. As well as also you can see this is the another web application. So basically in this web application I will try to add the trend inspection chart. So suppose in this time here you can see I can simply click on this map. Anyone can go to this web application and then click on this map. It's showing the result for what is the trend for a specific location. If the NDVI is the high and low, we can easily find out. So any region in this Bangladesh, so I simply click here. It's showing this the trend is the high and low. We can get this. As well also you can see we can easily measurement the precipitation using the Google Earth Engine platform, as well as we also try to make the land surface temperature monitoring using the Landsat 8 satellite imagery. Okay, so we are develop the model in Google Earth Engine platform. So but then I simply create the map for the Dhaka city, but we can easily use the data set for any region. Okay, and this is the another types of land cover classification map. So basically we classified the whole country boundary of Bangladesh and classified the all of the classes in here. As well as also you can see the assessment of the plant health status using the NDVI. So then we also try to come make the water quality analysis application. So basically in this time we are using here the Sentinel-2 satellite imagery. For the Sentinel-2 satellite imagery we try to extract the water pixel value. After the water pixel value we can just simply make the NDTI, normalized difference turbidity index. So turbidity, where we can find out the turbidity is the high, then it identify there is the polluted water, and where the turbidity is the low, we identify this is the normal water. We have developed this algorithm in Google Earth Engine platform and then create this type of lake water quality analysis map. As well as also you can see this is the air quality monitoring part. So basically in this time I just try to use here the Sentinel-5 satellite imagery and then make the concentration map in Bangladesh for year of 2019 and 2020, 2 time period we try to use, and then take what is the concentration of the nitrogen dioxide. As well as also you can see this is the another classification map. So mainly in this time we classified in here for the non-cropland, then cropland irrigation major, cropland irrigation minor, cropland rainfed, and minor fragments. We classified subclasses. Also you can see this is the another tags for the flood mapping using the Sentinel-2 satellite imagery. For in this time we are using here for only for the NDWI index. Then we try to identify the water's normalized difference water index on the 2 time period, dry season and wet season in Bangladesh. Also you can see this is the night light maps activity of Bangladesh. So basically in this time we try to observe what is the condition of the night time at Bangladesh. So here you can see, so mainly major cities in Dhaka we can get the more activity at the night time. Also you can see some other major cities, but when you can see in the Sundarban region, you can see there is a no activity at the night time. Also you can see the hill track area. Okay, also you can see the river. Okay, there is the black color, it's identified there is the no activity in the night time. As well as also you can see this is the another our research paper map. So basically in this time we try to use here the global gross primary production or GPP. So gross primary production or GPP, we can try to make the change trend of forest in Sundarban region, both Bangladesh as well as also India part of Sundarban. Okay, in this time we can just make this analysis using the Google Earth Engine platform. After this we can download the TP image and then make the processing of the map using the ArcMap software. Also you can see then we also try to make the another research work for the relationship of LST, NDVI and NDVI in Dhaka city. Then we can create all of the map data using the Google Earth Engine platform. Then you can just simply download the data as a TP image and then try to make this type of map using the ArcMap software. Also you can see this is the another web application for detecting the wildfires in California 2nd, 9th and 12th September in 2019. So anyone can go to this web application and then try to easily for and detecting the wildfire in California. As well as also you can see this is another task for the so drought monitoring project. So in this time we are using here the standard vegetation index or SDI index and try to make this web application, and we can simply go to this web application link and click on the any point of the map. We can easily get all of the standard vegetation index pixel value, and we can easily identify where is the drought, moderate drought, severe drought. We can easily find out. As well as also you can see this is the another things. Mainly in this time we are using here the spectral unmixing model using the Google Earth Engine platform, and then we are classified the barren land, build up area, and water body using the spectral unmixing model. So also you can see this is the another snow cover map of Iceland. We are also creating this type of map using the Google Earth Engine platform. So also you can see this is the land cover classification map. So all of the things we try to use here this Google Earth Engine platform. Also you can see this is the another classification map of Punjab. So mainly in this time we have crop classification, rice, cotton, fodder, maize, sugar cane, wheat. We can classify it in here. Also you can see this is the another air quality monitoring maps. So mainly in this is our another research paper map. In this time we try to mapping the change in nitrogen dioxide concentration in the Dhaka city for the lockdown, pre-lockdown, and post-lockdown at the COVID situation. Okay, so you just try to make this map and try to check the what is the change in the nitrogen dioxide concentration. Also, you can see we are also doing for the some drainage map or hydrological analysis. We can also do using the Google Earth Engine platform, and then we can just make the drainage map of Rizukal Basin in Cox's Bazar, Cox in Bangladesh. Okay. Also, you can see this is the another for the sediment map. We also try to make the sediment map, then also try to okay, so this is the NDVI map, normalized difference NDVI map. We are also try to for the drought risk hazard index or DRSI index. So this is another project work. As well as we can also work for the another classified this is the Bhashan star. So basically this Bhashan star, here you can see there is the no settlement before year of 2020. After Rohingya refugee came in the Bhashan star of Bangladesh, then it also find out the settlement. So this is our another 10 trend analysis in the classified land cover maps of Bhashan star. As well as we can also get the some dam analysis, and we can easily make the digital elevation model or dam data. Okay, then also you can get the some precipitation data also in here. Also we can classify the land surface temperature classification maps on in here, and classify the low, sub low, sub high, and high. As well as we can see we are also monitoring the NDVI change detection using in map in the refugee camp. So here you can see year of 2015 there is the no refugee camp, then we can get the better vegetation. But when the set up the after 2017 set up the Rohingya refugee camp, you can see this vegetation is the decreases, and we can get the lot of settlement in here. Okay, so in this time you can see I also work with some book chapter and publication. So this is my ResearchGate profile, Research Scholar profile, and LinkedIn profile. So basically in this time we are also working with this book chapter. Okay, sorry. So okay, so this chapter, this is the climate vulnerability and the resilience, the global south. So this is our I am also co-author in this book chapter in here. As well as I also work with the assessing the impact of COVID-19 lockdown of the surface urban heat island and normalized difference vegetation index in Dhaka megacity of Bangladesh. So we also try to work with this, as well as also work with the special temporal analysis of urban eco environmental quality of an urban area using the geospatial techniques, the case of Dhaka megacity. We are also working for the estimating the impact of land use, land cover change of an ecosystem service value in heavily urbanized city of Bangladesh using the Google Earth Engine. As well as we also work for the modeling the impact of the land use, land cover changing pattern, and urban thermal characteristics in Kuwait. As well as we also working for the assessing the predicting land use, land cover, land surface temperature, urban thermal field variance using the Landsat imagery for the Dhaka metropolitan area. As well as we also try to complete the one kind of web project using the Google Earth Engine platform for the assessment of the agriculture drought monitoring for the. So basically this is the one kind of university's project work in Pakistan. As well as we also try to okay, so this is our another work for the Ethiopia. So basically in this time we identification of the suitable land for livestock production using the GIS based multi-criteria decision analysis and remote sensing in the this Ethiopia, this region. Okay, we'll try also try to add some analysis. So then I also add the co-author on this paper. Okay, so as well as I also try to show you the directly some my web application from the Google Earth Engine platform. So just a minute, I simply open my code editor and try to show you that.
Yeah, hold on 1 second, okay?
Yeah.
1 second.
Yeah.
So go ahead.
Okay. So in this time, I simply opening my some web application. Suppose I want to work with suppose water quality, and I simply open this web application, and then I want to just try to calculate it some water quality parameters from this web application. So this is the user interface of this web application, and in this user interface we can easily add our observation time period. You can see and date slider. From the date slider I can simply select my observation time period. Suppose okay, so I simply randomly take the time period like this, and also in time period is that I simply put this time period. Suppose so I simply put the time period like, and then I can suppose in this time I want to observe the what is the condition of the water quality in this region. I simply draw the ROI, and then I simply just draw my region of interest. Okay, then I just simply select the value. This I want to calculate it. I want to calculate it the turbidity. So I simply select the turbidity and then simply the submit. So now you can see when I click the submit, it's showing the creating the legend, as well as also it creating the GIF animation, as well as also it's showing the time series chart between this time period. What is the condition of the turbidity of this place? We can identify, and we can easily click to here. You can see now we can get the chart look like this. And then if you want, you can download the CSV file format of this file. Simply download. Now this chart data is downloaded as a Excel file, and if you want you can download the PNG file format, as well as suppose I want to calculate the chlorophyll on the water body. Simply chlorophyll and try to click to the submit. So now I get the what is the condition of the chlorophyll index on this region. I get this in here. So now you can see, okay, so I can get the time series chart also in here, as well as I want to calculate the total suspended solid or TSS, then submit. So now I get the result. What is the condition of the total suspended solid? I get, okay. So and also I can get the between this time period what is the condition of this total suspended solid. When the total suspended solid is the high and when the total suspended is the low, we can easily identify from here. As well as we can also download the data in Excel file and download the PNG file format of this chart. Okay, so this is the one kind of web application for water quality analysis. As well as also you can see the
Can
yeah.
you just one sec, Mijan?
Yeah.
What's the time step on the time series? Is it like pulling in every like 10 days, 1 day? What's that time series?
Okay, so we can get the data set for every 2 days interval. So you can see
Okay, so this is a Landsat imagery, or this is
Sentinel
what image
imagery,
it's pulling?
Sentinel-2 satellite, Sentinel-2 surface reflectance imagery.
Okay, so it's using the Sentinel-2.
Yeah.
Okay, and then every 2 days it's pulling in.
Yeah, yeah.
You have a time series like March through September or October, right? I see only like a few values like that.
Yeah, yeah. So,
So
this
it's
is
not
the
it's not
March.
every 2 days.
Yeah, so it's the March. Then we can get this January, February, March, April, May. Okay, so every 2 years. So if you download the data, I can simply download. Then we can get easy. Okay. First date I can get the 14th February, then second 24th, then 3rd March, then 6th March, then 13th March, 23 March, 17th April, 18 December, okay, then 14th February, then 1st March, 11th March, 22 October, 7 October, 29 October. On this time
So
period.
it's not consistent, or is it like all over the place? Or
Okay,
is it
so
like
it's not
you said every 2 days, right?
Yeah. Okay, so basically in this time, this data set, it's not consistent, but in this time we can get the data set and inconsistent series. Okay, suppose sometimes this satellite image is not available for this, but then it also covered the another time period satellite image. Okay, then we can get the result in here. Okay.
Okay. So it's whatever your available satellite images for that region, it's pulling in downloading Sentinel-2 for that region, right? That's what you set it up the code to be.
Yeah. So basically, if you in this time, if you want to check the Sentinel-2 satellite RGB color, also it will be available. So you can say simply submit. So now I can get the result for the Sentinel-2 RGB color also in here. So this is our Sentinel-2 satellite image RGB. So in this time, we can also we can get the animation. What is the changing animation between this time of this satellite images? You can see. And then from this, I use this code. In this code, we are using here the some method. Okay. So first, okay. So I also try to show you the some method. Then I simply show you the source code. Okay, so basically in this code, I try to show you this algorithm only. Just a minute. Okay, so in this time we can calculate the NDTI, and we can use this formula for calculating the NDTI. All of the calibrated formula we can add this, as well as we can also use here the watermarks. For the watermarks, we are using here the automated water extraction index. So automated water extraction index we are calculated for extracting only for the water. We are also calculated the NDCI index by using this, as well as we can also calculate the NDWI, as well as you can see this is the formula. So this is the formula for the water automated water extraction index. Then we are also using here the total suspended solid by using this formula. Okay, then total suspended solid, we can get this result, and basically this is our method. Okay, this is our methodology, but in this time this methodology we also try to express the method into the web application of the Google Earth Engine platform, such as when I click to here, all of the things I add here as a web application, so anyone can use this web application and get the real-time data, and this data set is automatically updated, such as at the present time which data is available for the sentinel surface reflectance. We can get the result for this satellite images for the water qualities, different types of parameters. Okay, so we can add all of the time slider, then anyone can draw the ROI also in here, then anyone can select their value. Okay, then you get the result. Okay, so this is the types of the sentinel-2, as well as also thing is that another code for the water quality is for, I will try to show you that. So this is the okay. So this is the water plus land use land cover. Also, we can combination of the this another types of research work for make the water quality analysis for the river, and at the same time we also try to identify the different types of land use land cover features, such as agriculture, savanna, forest, water bodies, mangrove, build up area. So I simply click to the run. So in this time we are also using here this Sentinel-2 satellite imagery for Sentinel-2 surface reflectance satellite imagery. So I simply run this code.
So, Minjan, this code that you developed, you seems like it's you published this. Is people actually using your code to predict, or is it uh, just for research purposes? You kind of are you? I'm assuming like all the you're running it on a Google Earth Engine, right? All this on the server
Yeah.
on the Google Earth Engine. So and people can come in and they just run it automatically. Is it open to public, or is it just a research purpose you are using?
Okay, so basically all of the data set is the openly anyone can use, but this algorithm need to develop. Okay, because Sentinel-2 satellite imagery is already available, so in Google Earth Engine freely we can use this, but we also need to develop the some code for getting this type of result or getting this type of analysis.
Okay, so so you developed this algorithm. Is it open? You released it, or is it just you just
Okay, so in this time,
training
yeah.
people?
Okay, so in this time, this had the some algorithm. I also try to find out the traditional way paper. Suppose I want to some read journal or paper. This they are also using the remote sensing technique, but they are also they are not using the code. They are randomly use the ArcMap software and make this type of analysis or make this type of map. But in this time, the same tasks or same mapping, I also try to use the coding. Suppose you can see this is the one kind of land use land cover classification map. Anyone can you get the result from the satellite images and download the satellite images and import the ArcMap software and do a lot of process for making the traditional way for making the land use land cover classification map. But at the same time, if you want, you can use the code in Google Earth Engine platform and you can get the result very quickly and efficiently. Okay, in this time I just turn into all of the algorithm from the traditional paper, then they are using the ArcMap or QGIS software, Then I simply get their algorithm and put their algorithm into the code and make the
Yeah,
analysis.
yeah, yeah, yeah. And this algorithm is public, or you're using it on your own research purposes?
Okay, so now in this time, all of the code, all of the online training program. So basically, in this time, I will. It's not publicly available. So who can join with my online training program, or who can get the some project work such as different types of freelancing working. Then I also try to add their. So they can also send me their region of interest. So this region they are need for the water quality map or air quality map. So I simply put all of the code of the analysis for their area and submit this project work, as well as also send the source code. Okay, they can easily.
Okay,
Yeah.
okay, I gotcha. Okay, so this is very cool, very cool. Can you do one? You can do this any. You can do water quality in this any region, right? Any region on this.
Yeah.
What's the resolution on this? Is it 30 meter or is it 10 meter? What is the resolution on
This
this
is a
water
10-meter
quality? This is a
resolution.
raster, right?
Yeah, raster. Yeah, raster. 10-meter resolution.
10 meter, you said?
Yeah.
Okay. Can you go to one region? Can you go to the Midwest? Like, can you search Kansas City, like the region that I'm in the United States? Uh,
Okay, just a minute. I simply open the code and that's the region.
so it's a Centennial 2 is a 10 meter resolution images,
Yeah.
essentially. That's what it is. Okay.
Okay, so I simply click the run. Okay, so basically, this code is for the Dhaka city. Okay, this code is the Hatirjil Lake. Okay, so suppose in this code I want to also use for the any region, any water body, and basically this is the showing the result as a turbidity. What is the turbidity? Changes or okay NDCI. Sorry, this is the NDCI for the normalized difference chlorophyll index NDCI. So mainly NDCI formula is that B5 and V4. In this time we are using here the satellite image for the Copper Sentinel 2 surface reflecting satellite images. Okay, then I just try to add all of the things, and then okay, so this is my true color image. Right? So this is the true color image. Okay, in this true color image, in this time we are using here the surface reflectance for the water surface reflectance, and then I calculated the NDCI, and where I can get this type of this red color pixel value. It's identify that the lot of NDCI, a lot of increasing the chlorophyll, and where the increasing chlorophyll we identify this is the polluted water. Okay, so in this time suppose I want to use this code for other region. So what's the region name?
Kansas City.
Please spelling.
KAN. Yeah, I'll
K-E-N.
type it in here for you.
K-E-N.
I'll type it in the chat. Hold on. Yeah.
Okay. Okay. Okay.
Wait, can you zoom into that? Where you see the overland park right there? Yeah, can you to the right, to the middle?
Okay. So
Can you zoom out a little bit? Just
okay.
okay. So you can. I was just gonna find the region. Hold on. You may need to go to the east. We can find some lake there, and or river. Zoom into that. Yeah, that area where you have the mouse right there. Okay, just pick up any region there.
Okay.
Yeah, right there.
Okay, so I simply remove my previous ROI. This time I just simply so I simply throw this ROI in here. So if you want, you can also take the only for the river area. But in this time so I take
Okay.
the river area. So I simply take the river area, and I can also use the satellite image, or I can so randomly you can take. So in this time I simply take this river area for. Suppose this is my area, okay, and then I simply
Yeah.
put this name such as ROI, and then click the run. We can get the surface reflectance. So NDCI. So okay, so in this time we can also get some region there is the it's not take the water pixel. So in this time I think we also need to increasing the value for the water pixel. So it will be set from the greater than negative till at the greater than 0. Then click run again. If you want to check the value, I simply click on here and click on any red pixel area. I click here.
Mhm.
Now I can get the what is the value of the NDCI for a specific coordinate.
Yeah.
I can get the NDCI 0.7. So high NDCI or high NDCI value I want to get. So high NDCI value mean that there is a lot of chlorophyll index is available for this region. Suppose I simply click on this here. Now I can get what is the condition of this lat long. You can see it provides the specific lat long as well as it's also showing the 0.6. When I click on the normal water, suppose this is this type of water I click here. So now I can get the you can see NDCI is a negative. So negative NDCI is identified. This is the chlorophyll index is the low. There is the very low. So when I can get the high NDCI value, it's identify the high turbidity is concentrated on the water. Okay, so in this time you can see this place is also high concentrate of the water that chlorophyll. Okay, so also 0.6 we can get. So as well as we can also take the some other region. Suppose I can simply click this value
Yeah.
0.2. Okay, so this is a
Yeah.
low. Then so red pixel value here I can get the red color. It's identify there is the high NDCI value. The 0.4 you can see, and this color you
And
can see.
yeah, this one is run for like the whole year. Like you ran for other ones. Is that
So
what it
in this
is?
time
The
here
time
use here the
period.
year of 2021, and we can just take the image for the first image, and in this time you can see between this time period I can all between this time period I short according to the cloud pixel percentage. So between this time period it's take only for the one image means that from between this time period for year of 2021 I don't know what is the lowest cloud pixel percentage of the image for this region. I don't know, so that's why I use here the short function. So short function help you to identify the low cloudy pixel image. Okay, then I simply use this. Suppose you want to use here the all of the image, so then you can also use here the another function. Suppose I simply use here this suppose filter metadata function, filter metadata. I want to need only for this image, which image will be not more than 1% cloud pixel. I simply copy this property name and paste here, and then I will simply set the less than suppose 1, and all of the image between this time period I want to create the suppose median composite. I simply use here the median composite and click with the ROI, then click to the run. So now you can check what the result you can get. So in this time I take the lot of image, not only for the single image. So I take the lot of image, and then in this time you can see we can get the result very well than first time. Okay, first time we can also get the some gap filling. Okay, gap filling we can get there. Suppose one satellite image is not covered your full area properly, one satellite image or one tiles is not covered the fully your this river is not covered. Suppose in this time here I use between this time period, if you want to check how many images you want to get, so I simply show you that. So I simply click and simply just use here the print function and check how many images is available for the river. So I simply use the print function, then call my object name image, and then I simply print this in here and just use here the size function. So now I check how many images are available for this region. I can get 28 images. Okay, so for this area here I find out total 20 tiles or 20 tiles image I will find out. So 20 tiles, from the 20 tiles I get the median pixel value. So in this time when I use the median function, it calculated the total 20 images median pixel value and create the one composite, but it created from the 28 images or 28 tiles. And then click with my shapefile, and when I just click to the run, I can get the result properly. And you can see now it's showing the result look like this. Okay, and it's also covered all of the area from the surface reflectance satellite images. It also struck first of all NDWI, so it struck the water, and from the water it also showing the result for what is the condition of NDCI or normalized difference chlorophyll index. And where we can get the chlorophyll index is the high, we can get the color as a this red color, and then normal we can show this this type of paste color we can use here. So now you can see we can get this result NDCI. Now if you want, you can easily export this map, or if you want you can check the particular value. So you can simply click on the inspector and click on this. You can see now I can get the, for the red color I want to get the high NDCI value. Okay, you can see 0.2. For the paste color you can see I can get the low NDCI value. Okay, and then you can also get the coordinate like this. Yeah. If you want, you can also,
this is pretty good, man. Yeah.
If you want, you can also add here a time series chart. So between this year, when the NDCI is the high and when NDCI is the low, the same process we can apply in here. So when I want to calculate the chlorophyll, you can check for this region, we can apply the same process for the chlorophyll index. So now it also provide you the when the chlorophyll is the high and low on this place, we can easily identify from this time series chart. Okay, you can get the chlorophyll value also. I also get the changing animation.
Yeah, this is good, man. Yeah, good.
As well as, okay, so
can you do one example on the flooding? What do you do with flooding?
Okay, flood
mapping. I know you've done some flooding, right?
Yeah. So it's also just a minute. So mainly in this time we can also try to add the flood mapping as well as also add the flood damage assessment. Suppose how much cropland will be affected, how much urban area, or how much build up area, or how much how much cropland or how much settlement is affected. We can also measurement by using the Google Earth Engine platform by using the flood mapping. So I try to open the code.
What satellite image you use for the flood? Is it use the Centennial too, or uses different satellite?
So in this time we are using the two types of images. So Landsat or Landsat imagery is also available for the identify the flood mapping, as well as also we are using here the Sentinel 2 Sentinel 1 satellite imagery and Sentinel-2 satellite imagery is also available. So okay, so this is the one kind of another web application for the map. Okay, so in this application we try to make that real-time different types of data such as nitrogen dioxide, aerosol, carbon monoxide, formaldehyde, ozone, sulfur dioxide, methane. We can easily select any types of cache, any types of data set from the application. If you want, you can also set here your time period, okay, as well as also we can get the show the legend. Okay, so we can simply draw the ROI. So this is another web application. Okay, so I simply open the flat of that. The flood inundation map. Okay. So in this time here you use here the Sentinel-1 star data set. So I simply click the run. Okay. What is the problem? Okay, so I'll also check the code later. Getting some problem. Flood map of video. We're also using here this for the Sentinel star data.
Hold on, my son is calling me. One second, okay?
Okay.
All right, I'm back.
Okay. So basically, in this time, this flood mapping, we try to get the result from the Sentinel-1, as well as we also try to make the land use land cover classification map, and then calculated how much area is affected by the flood. Okay. So basically, in this time, we can see this legend is a potentially flooded areas. So in this time, this place potential flooded. Then affected are the cropland. So this is the affected by cropland of this flood, affected by urban area. Okay, we can also try to add this, as well as we are also estimate the flood status between this time period. Okay, between this time period, and we can estimate the flood extent area. This the total this area is affected. Estimate number of the people, how much people. Basically, in this time we can get the population density data set is also available in Google Earth Engine dataset, where we use the GSSL dataset for year 2003. This dataset we can use for this. Then we can also estimate the affected cropland, how much cropland is affected in this area. So basically, in this time, this dataset we can use for the Moody's land use land cover dataset. Okay. Then also use here the estimated the urban affected areas. How many urban affected area is affected? Okay. So 324 hectares. Okay. This is the flood mapping. We are also use this mapping for the flood, and we also identified the potentially flood affected urban, affected cropland, and also estimated the all of the area. So as well as the flood mapping, as well as also making the code for the flood damage assessment, how much area is damaged in here. So this is a Sentinel-1. If you want, you can also use the Landsat imagery for identify the flood inundation map. It's also possible.
Okay. So what's the resolution on Landsat imagery? Is it 30 meter or 10 meter?
30 meter.
30 meter, right?
Yeah.
What about the Centennial? If you use a Centennial, that's 10 meter, right?
Yeah, 10 meter. Yeah.
Okay. So if you use the Centennial, you may get more accurate results, right?
Yeah.
Probably.
But Sentinel image has has not the long duration. When you want to work with the long duration research, then we need move to the Landsat imagery. But short
How
time period,
frequent?
it's okay.
Yeah. How frequently you can get the image for this region?
Yeah.
What's the frequency?
Yeah. As well as
so Landsat, you said like what's the frequency you can get? How frequently you can get for Landsat?
so we can get the frequency of 4 to 5 days. 4 to 5 days.
4 to 5 days.
Yeah.
Like so, every 5 days, it goes through. You have some image in any part of the planet.
Yeah.
Essentially.
Yeah.
That's Landsat. What about Centennial?
Sentinel is the 10 to 14 days. So we can see also trend AVI NDVI trend railway transaction. So this is our another web application. So basically in this web application we can check what is the condition of the NDVI. So basically this is the Saudi Arabia region. So this is another project work for the Saudi Arabia region. Suppose I want to check for this. So there's a very less vegetation in this region. So I just simply try to work with. So I simply click here. So this is the cropland. So this code is not completed yet. So I also work with this code. And then so basically this is my one of the project work for making the LST as well as also LST and NDVI. This type of LST NDVI. So anyone can click on this map. It's showing the what is the trend of the LST, what is the trend of the NDVI. With ongoing project work also working as well as so also air quality. So air quality monitoring. So basically this code I just try to add all of the things. Suppose in a particular time period you want to observe how much methane or how much nitrogen dioxide or how much carbon monoxide is emitted in a particular time period in a particular region. So you can easily calculate. You can see. So basically in this time I just total nitrogen dioxide emitted in 2021 any type particular month we can get the find out the 648.067 ton. Okay, nitrogen dioxide is emitted in this Ghana region. We just try to complete it. In this time we are using either Sentinel-2 Sentinel-5 satellite imagery for Copernicus Sentinel-5. Okay, then we use here the nitrogen number column, so you can get the year of 2020. So 1st January, so in the month of January 2021 we can get this region total emitted 684.06 ton nitrogen dioxide gases. Okay, and where we can get the high density, you can say high density showing this nitrogen dioxide is the red color. Okay, you can easily get this. This is another thing of water. So as well as so also you can see this is another web application. So basically this web application calculated the different types of indices such as all indices. I try to add all of the indices, and this code is also working. So we just make a web application. So using this web application, anyone can calculate any types of indices. Here you can see anyone can select their area. So suppose this area I selected. So I just simply selected this area, and then anyone can select which image you want to use, Sentinel-2 or Sentinel. So I want to use the Sentinel-2. So then after click the Sentinel-2. Okay. Sentinel-2, then you can see all of the index. So ARI, ARVI, BI, BD, PNDVI, so GDVI. So I try to add all of the indices, GCI, IPVI. So anyone can click on any index. Suppose I want to click on this any number of index. Suppose that I want to work with the suppose so NDVI. Also you can see NBR. Okay, normalized difference burn ratio. We can also NDMI. So we try to add PVI. We try to add all of the index TCI or VCI or okay. So you can see we try to add all of the equation, all of the index in here. So anyone can use this web application and easily get for the any region get this type all of the equations. Suppose a Savi index. So I simply Savi, and they can easily select the time period. They start time and end time. They can easily select it in here. So they can simply get the calendar look like this calendar, and they can simply select the time period look like this time period. They can simply select, also selected the in time period, such as I simply the time period over this time period, and then click to the run. So when they click to the run, it generating the time 3 times reach chart. So between this time period, what is the maximum savvy index, what is the minimum savvy index, and what is the uh, average savvy index. So maximum, minimum, and average, it creating the time series chart, 3 times series chart for this region. So which region I selected in here, and we try to develop this code, and anyone can easily get calculated any index as well as also calculated the time series chart for the 3 different, suppose average, maximum, and minimum condition of the savvy index, SAVI. Okay, so any types of index, and this is our source code. In this source code, we try to add all of the index equations, such as, okay, so all of the index equation we try to add in this code, and then you can see all of the equations, CI index, DVI index, EVI index. Okay, so all of the index we want to add in here, and then develop this web application look like this.
Okay. This is good, Mejan. So you said like you also do freelance for other companies, right? Are you looking for? Do you have time to help us if we need to hire you to do some work for us?
Yeah, so no problem. So suppose if you want, you can also need any types of project work, or you can just contact with the details what requirement you want to need. Then I also try to complete all of the things, and you can also get all of the source code. So basically, you can see when you can get the source code, then you can easily use the source code for any types of analysis for the other region.
Yeah. So mainly we will be interested, like we'll be interested in like water quality, and then also the flood inundation map. I know that NASA publishes the, you know, they have a different system to look at the flood inundation map and flood depth. I was doing some research on that, and they're doing that. But I think the flood inundation would be a huge the damage assessment. We probably need some help. But the thing is, like here, everything runs on Google Earth Engine, and it generates the raster, right? Where is the raster stored? In Google Drive, or is it stored on some kind of a storage unit in the server? Where is that all the shape files and everything is stored?
Okay, so basically we can easily export our own shape file in the asset tab. So asset tab is mainly managing your all of the asset which you uploaded in your shape file. So here you can say I uploaded the different types of shape file for my different type of work. So here you can see, so asset tab, we can easily export our own shape file in the asset tab, and which area you want to need, we can just the shape file. Okay, shape file we need to the only for the 4 file dot ssp, ss, and prj, and dvf. So you can see ssp, ssx, dvf, and .prj. This 4 file you want to need when you want to upload one shape file. Okay, and when you upload the shape file, you can easily use the shape file in Google Earth Engine platform for these different types of area, different types of analysis we can easily do. And finally, if you want, you can also export the different types of data sets. Suppose you can export the different types of raster. Suppose you can see this is the map or raster image for the NDCI. So if you want, you can easily export this map and you can simply import this map in ArcMap software and make the map layout, or make the other. Suppose you can see. Okay, so I simply open this some air quality map. So you can see this air quality map. Suppose you can see this is the map. This map I created all of the analysis in Google Earth Engine platform. You can see. So this is the nitrogen concentration map of Bangladesh. But when I want to make my research paper or my presentation work, then I can simply download the raster image from the Google Earth Engine platform, and then I can import this image in ArcMap software. After this, I create this map look like this for my research paper map as well as also my presentation map. The same way also you can see this is the, okay, so this is the NDWI map. So water surface, water index of NDWI. We can get all of the analysis in Google Earth Engine platform, and final product we can download as a TP image and work with the ArcMap software. Okay, also you can say NDVI map. So all of the things we can easily download it as a TP image. Okay, from the Google Earth Engine platform, and more the further map layout or other things we can use for the ArcMap software. for our research paper or other things. Okay.
Yeah. We probably we don't. Yeah, we use religiously use Mapbox, or Mapboxes are kind of the
Yeah.
front end piece, but we have a Google. We can set up a Google Earth engine pretty easily and get this. We can hire you to do some. The flood inundation map. And what we probably want to do is we want to automate some of the stuff, like the area of interest. Like if I push the shapefile to you,
Yeah.
it should grab those area of interest, and then it needs to calculate the flood inundation map, and then generates the raster and send it to our server somewhere so we can go and pick it up on the fly and then put it on the map. We can do that. So yeah, that's something that we can talk about it. Like how many hours per week can you help us? Like uh, is it, I know you're a student, but you're
Yeah.
also
Yeah.
doing a lot of other stuff. So how many hours per week can you help us?
In a week or in a day.
Yeah, in a week. Yeah.
Okay. So basically, in this time, so in a week I can help. So total, I think 10 hours
So
in
like
in a week.
10 hours a week total. Is that what you said?
Yeah. So 10 hours in a week.
Okay, that's a little bit less than I was expecting. I don't know if you have time more than 10 hours. Um, um, okay, what's your, do you charge by project or do you charge by hourly rate?
Okay. So I think it also better for the hourly.
Okay. What is your hourly rate?
Okay, so basically, in this time, hourly I can. So basically, hourly I can take the charge for this $100.
So you charge $100 per hour?
Yeah, yeah, hourly. So and I also work. Also try to show you this. So I also work on the Fiverr as a freelancer. So basically, in this time, I also as a level one seller in this freelancer in here, and I also work for the different types of analysis using the Google Earth Engine platform. Okay, so basically hourly I can charge for the $100, but if you want, suppose if you want, you can also take for the full project work. You can share your project, all of the details. Then I also show you all of the how many times I want to knit. Okay, then it's also depend on your project work. When I want to work with your the project after complete your project algorithm, all of the things, then it also depend on your project work. Okay.
Okay. All right. That's good to know. Okay. We'll keep in touch. That's good to know. I'll reach out to you on LinkedIn. I'll probably, I don't know, maybe we just hire you hourly. I'll talk with my co-founder. What are the things you need to do? So for Sud, can you give me an example? You already have the tools for the flood inundation map and water quality. So if we need to set something up on the Google Earth Engine for the water quality and flood inundation map, do you know how many hours that will take?
So basically, in this time, in this time my system, my code is already developed. Okay. So in this time I just need to modification.
Yeah, yeah.
Okay. So for
So it's
your
not going to be
area,
too
yeah,
much effort, but we can hire you like 10, maybe 20 hours, like a 50, 100 hours or something. So you can kind of help us set up everything on the Google Earth Engine, and then we can, uh, take it from there. You
yeah.
think that will work?
So basically in this time, I can charge only for the code, because when I give you the code, source code, and you can easily modify all of the source code. Suppose you can easily change the area, you can easily change the date time period. So all of the things you can easily do, and using the same code for the different region. So any region you can
Yeah.
use the same code. You can easily get the result. Just change the area.
Yeah, that we can also do. But I think we probably need some help setting up just to make sure, if we need to do any modification, apart from not from the area of interest, but different. Suppose the way that you calculate certain things, that if you need to do any adjustment, if you need some help, you can help us, right?
Yeah.
So you can do like set up the initial setup of Google Earth Engine and then the flood inundation map and the use of the code. Maybe if you can give me some rough numbers, that would be helpful. Like just to give me water quality and flood inundation map, and we'll help you set up those two first. Maybe you have to buy your source code, so we can kind of modify any area of interest. But like setting up the Google Earth Engine in our server, setting up the source code so we can automate some of the stuff.
Yeah.
Probably you may charge like 10 hours to set the whole thing up, and then whatever the cost for the source code, you charge for it. I think you said like if you take the course, you will give it as a free or something. Is that what you said?
So if you okay, so these are another such as anyone can join my online training program, okay, and they can get all of the details from beginners to advanced who don't have anything about the coding, about the Google Earth Engine function, about the Google Earth Engine server function. If they want, they can easily join with my online training program, and they can easily learn all of the things. And all of my students who join with me, they can also get the freely code materials or practice code they can get.
Yeah. Okay, so maybe we just buy the source code from you, all the source code, whatever you charge for your student, and then plus we will pay you $100 per hour, but we probably need only 20, maybe 40 hours from you, and then we can consult with you. Hey, if you need to do a modification, you can help us out. How would that sound?
Yeah.
Sound good?
So I think it's also better. So when anyone can join with me and learn all of the things, and they can easily modify all of the code. Okay. And in this time, they need to learn the full course without any short course is not. So basically, any student who want to join for the air quality monitoring, they can learn all of the things for the air quality monitoring without a web application. So it's not completed for learning the Google Earth Engine platform. So when you want to learn the Google Earth Engine platform, you should to learn all of the things, all of the user interface function, all of the things you need to learn. Then you can easily apply your own algorithm easily in Google Earth Engine platform.
Okay. Yeah. Okay, that sounds good. And what's your total cost? You said like I don't know how much your course cost. Is it the total course? How much it's cost?
Okay, so for the total course, in this total course, we are separate the some. Suppose first of all, 3 days for the primary. So who don't have anything about the programming, they can learn for the 3 days all of the programming language with Google Earth Engine platform. Then we also provide the 7 days. So in the 7 days, we also try to discuss all of the application of the Google Earth Engine platform without web application. And then last 5 days, we try to discuss about the web application. So total 3 plus 7 plus 5.
Okay. How many days? How many hours a week? I can ask one of my developers to join your course.
Okay. So basically, in this time, each day we provide the 3 hours. 2 hours is for the online training, and 1 hour for the problem solving class.
Okay. And that sounds good. So maybe I'll ask somebody to join the course. We get the whole course material.
Yeah.
And I don't know if they're able to they have time to sit through all this stuff, but we also we'll pay you your consulting fee. So you can help us set up everything. I mean, they will probably learn with on their own limit, but maybe you can help us setting up the initial stuff. That would be helpful. So what is your total cost with the source code? Can you give me some number?
So do you want to need all of the source code? Yes.
I don't know. I mean, you have a lot of source code. We probably
there's
don't
a
need
lot of
all
source
of
code.
them,
So basically, in this time, you can see. So basically, I also work for the Google Earth Engine for the total 5 years. So 5 years, I also try to working the Google Earth Engine platform. So there's a lot of code. So in my script tab, there's a lot of codes available. So in this code, you can get all of the code. And when you want to learn the basic things of the Google Earth Engine platform, or then you can easily modify all of the code. Such as you can easily modify, you can easily get the result. So it's very easy way. Okay. So basically, as a student who don't have anything about the Google Earth Engine platform, I think this is the best way for, because they can easily get all of the practice code, and when they practice they can easily learn all of the things.
Okay. All right. That sounds good, Mijan. I appreciate your time, and I'll connect with you on LinkedIn. Maybe we hire you for like 10 or 20 hours just to help us with Google Earth Engine. But I'll ask one of my developers to join your course, and everything is recorded, right? So they can watch it anytime, right? Or is it not?
Yeah.
Your course, when you do the training, you send the recordings to the students, or is it?
Yeah, they can also get the privately recorded video class. So I guess, suppose
Okay.
when a student join with me, I can give the privately access only. Suppose he can get the Gmail, this Gmail I can give you the privately access. So only you can see my recorded video class.
Okay. All right. Cool. So do you have any other questions, Mijay? Do you would you will you I mean, you said like we can definitely work together, on with mainly we're interested in water quality and floodplain, the flood inundation map.
Oh,
That's two I can think of I can use right away. And then we'll consult with you like, as needed basis. So
okay. Okay, so no problem. So you can choose your region of interest and also your time duration, all of the things you can send me. Then we also try to discuss about this, complete the project work for others.
okay. All right. Thank you, man. Appreciate it.
Okay, thank you. Okay. Okay,
All
bye.
right. Bye.
Goodbye.